to Hassan's Maths channel. I'm now answering question number 2 from the October 2024 Pure Mathematics P1 paper from the International A-Level Edexcel exam. And here we have a question about indices. So we've got to simplify fully this, kind of like algebraic type of fraction, where everything is, x and y's to different powers and so on. So we're going to use a few of the important laws of indices that we should know. And I'm going to use this as an opportunity to just go through some of those laws to make sure everyone understands what's going on. Okay, so I'll make it a line here where I'll separate my working and some of the rules I'm going to discuss. Okay, so now, so what I'm going to do first is I'm going to rewrite this as, there's different ways to do this, by the way, but maybe I'll show you both ways. I'll see at the end. So 3y cubed times 2x to the power 4 to the power of 3 divided by 4x squared y to the power 4. So you can think about it like this if you want to. Now what I'm going to do first is I'm going to deal with this part here. Okay. So there's two rules that I'm going to apply to this. One of them is the rule of indices, where you have a product of two, terms, different bases, raised to a particular power. It's the same as raising them individually to that same power and multiplying them together. So a to the power of n, ab all to the power of n is a to the power of n times b to the power of n. Okay, so I can write this, I can think of this as 3y cubed times, this is 2 to the power of 3, and then times x to the power of 4 to the power of 3. You can think of it like that. So this is to the power of 3 and this is to the power of 3, and this is divided by 4x squared y to the power of 4. And then what I can do is I can raise 2 to the power of 3 gives me 8, and then I've got to do x to the power of 4 to the power of 3. So this gives us the rule that a to the power of m raised to the power of n. When you have something like this, you multiply the powers out. So this is a to the power of m times n. And you can see this in action. For example, if you have, 2 to the power of 4 raised to the power of 3, it's like 2 to the power of 4 times 2 to the power of 4 times 2 to the power of 4. And you can, from the laws of indices that we already know as well, that when you multiply numbers in index form, if they're the same base, you add the powers. So it's going to be 2 to the power of 4 plus 4 plus 4, which is like 3/4. So it's like 2 to the power of 3 times 4, which is 2 to the power of 12. So that's where this kind of understanding of this rule comes from. So you have something raised to a power to another power, you multiply those powers. So this is going to be 3y cubed times, I'll put times now, 8, and this would be x to the power of 12 divided by 4x squared and y to the power of 4. All right, so now let's just simplify this a little bit. So you have 3 times 8, which is 24, x to the power of 12, y cubed, just writing in alphabetical order, divided by 4x squared y to the power of 4. And now we can divide these two terms. So you have 24 divided by 4, which is 6. Then you have x to the power of 12 divided by x to the power of 2. So you have to subtract the powers. Okay, and that's from the law of indices. A to the power of m divided by a to the power of n is the same as a to the power of m minus n. Okay, and you can see that in action. For example, if you have 2 to the power of, say, 4 divided by 2 to the power of 2, it's like you got 2 times 2 times 2 times 2 over 2 times 2, and 2 of the 2's cancel out, leaving you with 2. It's like when you subtract these two powers. All right, so this would be 12 minus 2, and for the y term, 3 to the y to the power of 3 divided by y to the power of 4 is y to the power of 3 minus 4. So you end up with 6x to the power of 10 and y to the power of negative 1. You can leave your answer like that, that's fine. You can also leave your answer as 6 to the power of x, 6x to the power of 10 over y. Both of those are considered correct. And that's fine. Okay, so, and one of the laws, as we mentioned before also, is a to the power of m times a to the power of n is a to the power of m plus n. We kind of looked at that law a little bit when we proved this. So here are some of the laws of indices that we used in order to simplify this fraction fully. Okay. There's also an alternative way of doing it. So if we start off with the equation 3y cubed 2x to the power 4 cubed over 4x squared y squared, y to the power 4, sorry. Then we can also do this by using the same ideas. First of all, expanding that. So you have y to the power. In fact, what we could do actually, if you wanted to, we could start by simplifying a few of those first. So we could, for example, start by saying, okay, let's cancel out the y to the power 3 and y to the power 4. So that gives me y underneath. Right, that cancels out. This becomes 1 there. All right, so they cancel out. It's kind of like you subtract the powers, but the y will be underneath here. But for the other thing, we have to first of all deal with this. So you have 3 times, as we said, this is going to be 8x to the power of 12 over 4x to the power of 2y. So that y is left behind. Now we can cancel out the 4 with the 8. That gives you 2 here and 1 here. I'll do that in a different color so that it's a bit clearer. So the 4 and the 8, that gives you 1 here and a 2 here. And x to the power of 2, x to the power of 12, that gives you x to the power of 10 here. So now we can write our answer as that's going to be equal to 3 times 2, which is 6, x to the power of 10 over y, which is the same answer that we got there. So we can do it by cancelling out first. Okay, here I went through some of the laws of indices and stuff, so it looks a bit longer, but whichever way you want to do it, it's up to you. So that's part 1, which is all about indices and laws of indices. And part 2 is about surds. So it says calculate the exact value of a such that 16 over root 3 plus 1 equals a times root 27 plus 4. Write your answer in the form p root 3 plus q, where p and q are fully simplified rational constants. So we have to deal with things in surd form. Now, what we have to do here in this question, we can't use a calculator for this at all. There's an a there anyway, but even if we try to just do 16 over root 3 plus 1 divided by 27, minus 4 divided by root 27, we could put it in a calculator, we'll get the answer, but it won't be fulfilling the conditions of the questions. Okay, where you have to show your steps, because it's very important. You show all stages you're working, and it's as if that's a non-calculator question, basically, right? So you have to show that you did this without using a calculator at all in any step. That's what you have to show. So what I would do first is I would say, okay, let's take this expression on this side of the equation, okay, and let's rationalize the denominator. So I'll keep this written as a root 27 plus 4. But what I'm going to do here, in order to make it simpler, it always makes things simpler when you rationalize the denominators. So I'm going to take this and rationalize the denominator, and hopefully that will make life easy for us. So to rationalize this denominator, I have to multiply by what's called its conjugate, by that term which will cause the square root term to disappear when you expand it. Okay, and so we're using the principle of difference of squares. So if I multiply this with the same terms but with the opposite sign between them, what's going to happen is the middle term, which will be the root 3 term when you expand it, will become 0, because you basically have root 3 times minus 1 and 1 times root 3, negative root 3 plus root 3. The root 3 term will disappear. When you multiply root 3 by root 3, it becomes 3. You multiply 1 by minus 1, becomes a minus 1. You won't have any root 3 term. All the root terms were gone. You would have rationalized the denominator, made it into a rational number, the denominator. But what you do to the denominator, you must do the same thing to the numerator. So I must also multiply this by root 3 minus 1 as well. Okay, I don't multiply this side by root 3 minus 1. Why? Because I'm not actually multiplying this side by root 3 minus 1. I'm multiplying this side by 1. I'm multiplying both the numerator and the denominator by the same thing, so I'm not changing its value. It's like I'm just multiplying by 1, but just, in a different format of 1. Root 3 minus 1 over root 3 minus 1 doesn't change the value of this, but it changes the way it looks. Okay, so now what I'm going to do is I'm going to expand the bracket. So I'll leave this as 16 times root 3 minus 1 in brackets, in case something cancels out and makes it easy for us. And this is going to be root 3 times root 3, which is 3. It's not 9, it's 3, because it's root 3 times root 3. And when you do root 3 times root 3, you can think of it in two ways. You know, it's just like, you know, the square roots disappear, you're left with 3. You can think of it as root 3 squared, okay, where they cancel each other out. So don't make the mistake of making it 9. It's like, you could say it's like the square root of 9, which gives you 3 in the end anyway, right? Like when you multiply two things, you have root A times root B. It's the same as the root of A times B. Okay, you can think of this in that way if you want to, or you can just think of it that the square root signs are cancelled out. And 1, as I said, the middle term will disappear. Root 3 times minus 1 is minus root 3. 1 times root 3 is root 3. We don't have to write that down, but we write down the last term, which is 1 times minus 1, which is minus 1. So basically, you see something like this where you have conjugate pair here. You just square one of the numbers and take away the square of the other. So root 3 squared is 3 minus 1. That will give you your answer. And that's equal to A times root 27 plus 4. So this is an equation. I'm writing this down because we're solving this equation. All right. So now this gives us a 2 underneath. So you have 16 times root 3 minus 1 in brackets over 2 equals A times root 27. Let's just simplify this as well. Root 27 contains a perfect square. Root 27 is like the square root of 9 times 3, which is root 9 times root 3, which is 3 root 3. So this becomes A. So you can say 3 times A root 3. 3 times A root 3. Okay. And you got plus 4. So just simplified that a little bit. And now we can cancel out the 16 and the 2. So it's 2 and 16. That gives you 8 here. So now we got 8 root 3 minus 8 equals 3A times root 3 plus 4. So we want to make A the subject. We want to find A equals. So I can subtract 4 from both sides. So I have 8 root 3 minus 8 minus 4, which is 12, minus 12, and that's equal to 3 times A root 3. So I can say A is going to be 8 root 3 minus 12 all over 3 root 3. Okay, all over 3 root 3. And now we can simplify this by rationalizing the denominator. Now in this case, to rationalize the denominator, because it's not a term of two parts where you have a rational and irrational added together, it's just 3 root 3. How do I rationalize that? Well, I just have to multiply by the surd, by root 3. If I multiply root 3 by root 3, it becomes 3. The surd has gone. It's rationalized the denominator. But I must also do the same thing to the numerator. I must also multiply that by root 3 as well. Okay, if I multiply this by root 3, I must multiply the top by root 3 as well. So now we can simplify this and give the answer in the required form. So A is equal to, this is root 3 times 8 times root 3. That's 8 times 3. Okay, if you multiply that, that's going to be 8 times 3 minus 12 times root 3 over, and that's going to be 3 times 3. I'll just write it in proper steps there. That's 3 times 3, and that's going to give a 9. But we can actually do something to make it a bit easier. We can take out that 3 as common on the top. So you have 8 minus 4 root 3 over 3 times 3. Okay, so I've taken out the common factor of 3. There's a 3 here, and there's a 3 there that's common. That's 3 times 8 minus 4, 3 over minus 4 root 3 over 3 times root 3. One of the 3's cancel. Now we can separate this into separate fractions. Why? Because they want it in separate terms like this. So we'll end up with 8 over 3 minus, and you're going to have 4 over 3 root 3, which, if you want to write it in the form that they asked us to, negative 4 over 3 root 3 plus 8 over 3. And there is the answer in the form required. It didn't say write down the values of P and Q. They just said in this form. So we leave in that form where P and Q are fully simplified rational constants. So P is a constant which is rational, and so is Q, and they're fully simplified. So there we have the answer to question number 2, part 2. Okay, so it's all about rationalizing the denominator and solving these equations. Okay, so I hope that was clear. Other questions from this particular paper can be found in the playlist on the top right of the screen at the end of this video. Other questions from the topic of indices and simplifying surds will be in the playlist over here. For both part 1 and 2, it's the same topic, basically indices and surds. You can subscribe to my channel by clicking on this link, and on the top here you can click to find the video which tells you how to use my channel efficiently. Thank you for watching, and see you soon.